Okay, today I'm going to talk about how to investigate the rate of transpiration. As we know that transpiration is the loss of water through leaves or through mesophyll of the leaves, which leads to transpiration stream or the movement of water up to the leaves. Now, when we measure rate anything is measured over time. It's a speed of something. So if I want to measure the rate of transpiration, I want to measure how fast the transpiration happens, how fast evaporation of water happens. That's why here we have bubble pottometer. You are familiar of bubble pottometer. Bubble pottometer, it is called by this because we introduce an air bubble or meniscus, and we measure the distance traveled by this air bubble over time. So when we have d over t, we have rate or speed. This device also, it could be used to measure photosynthesis, but the leafy shot should be enclosed by water, so the displacement of water moves the air bubble. But here in transpiration, I need to measure the rate of evaporation, so the water should go out freely out of the leaves. So we place a leafy shot here in this device. We change the independent variable that we want to investigate. If we want to investigate the light intensity, the effect of light intensity on the rate of transpiration, then we change the light intensity. All of us know how to change the light intensity. Either we change the potential of the light, or we change the distance of the lamp. We put it either closer or further from the plant. That's why it's very important to know the factors that affect transpiration. The same factors that affect evaporation. Here, if we look at this, temperature is directly proportional with the transpiration. As temperature increases, so there is more kinetic energy for particles to move and evaporate. Humidity is inversely proportional. Once we have more water droplets stuck in the air, there is no more room for any other particles to evaporate out of the leaves. Light intensity is another factor. As we increase light, we increase evaporation, and wind also. As we increase the amount of wind, or when wind increases, so it removes the water droplets that are found above the leaf, and there is more chance for another water vapor to go out of the leaves. These are the main factors. If you want to investigate of temperature, we change the temperature. If you want to investigate the effective humidity, we change the humidity by using boiling water. As we know, boiling water produces vapor. Once we use boiled water and once we use cold water. When we put boiled water next to the leafy shot, then vapor gonna go very close to the leaves, and it create like a humid environment. If we want the humidity absent, then we don't use boiled water. We leave it as it is. Or if we vary the humidity, we can use another water but with less temperature, so we have less water vapor going out. The same for wind. We can use fan, and light intensity, as we said, we can change the distance of the lamp or change the power. Now, as water evaporates out of the leaves, water should be sucked from here to make up the water loss. The plant sucks water from here or takes water from the reservoir or the tank. So the air bubble gonna move towards the plant. We measure the distance moved by the air bubble. Over time, we're gonna have rate. Okay, we have talked about the transpiration and the movement of water. Now we are going to talk about a translocation. A translocation is the movement of sugar, amino acids, and hormones across the plant. Translocation happens through phloem, and here are the main points how translocation happens. Water is loaded or transported by xylem, while sugar is carried by phloem. So please don't mix. Now, sugar, once it's transported by active transport through sieve tubes from the place where there are the source to where they are used. The place where they are used, it is called, or they are called, these places, they are called sink. So where sugar is moved, from where it is moved, it's called the source. To where it is loaded or to where it goes, this place is called the sink. Okay. Here, if you look, let's describe these sentences. A translocation moves the organic molecules such as sugar, amino acids from their source, yani from where they are moved, through the tube system of the phloem to the sink where they are used, across the sieve plates or the sieve tubes. Companion cells, we said that companion cells provide energy since they have a nucleus, while sieve tubes do not. So they need energy to transport sugar actively. So the companion cells give enough energy for these tubes. Now, once sugar is loaded, that means it collects water. So water goes with it, but water moves by osmosis. Whenever we have sugar is moving, that means water should follow it. Okay? Then this